building on to the equation or the standard form of a straight line. Now, I've given you a straight line at the origin. I've given you a straight line without any fancy movements that always goes through 0 and 0 on the coordinate plane. Let's now talk about straight lines where we see y equals mx plus c, or sometimes written y equals ax plus q. Now, we've already investigated, we've seen what happens when I have m and a, right? I told you that both of these are equivalent. Both of these happen to be the same thing. They happen to be the gradient. Okay? They happen to be the steepness, the incline, or the slope of a graph. And the bigger that number, the greater the incline. And positive or negative only tells you whether it's going to slope to the right, which if it's positive, or slope to the left if it is negative. Okay. Now, people, with this gradient, we now want to take this idea a bit further, and I've given you a few equations. I want you to continue using Desmos, and I want you to add a constant to each of the graphs. I want you to add a constant to each of the graphs, right? A value for C, right? I want you to add a constant, and I'm going to tell you what constant to use. Let's use 3. So remember, we had a few curves earlier. We had y equals a half x. We had y equals 1x, which we can just write as x, y equals 2x, y equals 5x, and y equals 10x. I want you to take each of those graphs, and I want you now to add a number to it. And I'm going to make that number plus 3, plus 3, plus 3, and plus 3, plus 3. Now, it's your duty to go to Desmos, and what should you do? You type in each of these equations, and you write down what your observations are. So pause the videos now, open up your web browser, go to desmos.com, start graphing, and tell me what these graphs look like, or what happens to the original graphs of a half x. Okay, so hello and welcome back. So now I take it that you've actually paused the video, you've used the Desmos.com graphing calculator to actually plot these graphs, and now you can start telling me what is the effect of adding plus 3, for example, right? Okay, so let me go and do it with you over here. Here you can see it's a half x plus 3, plus 3, plus 3. So do you see where this graph is? This one, 3x is also black, plus 3, 5x plus 3, and 10x plus 3. So it used to be a graph all the way down here. The gradient didn't change. The incline didn't change. Let's just switch a few of this off. And let's just put down y equals a half x. Right? So this is y equals a half x. And then this is the graph of y equals a half x plus 3. And this one here is y equals a half x plus 3. So what are your observations? We had a graph down here. It was going through the origin. This was plus 0. Okay, this one was plus 3. Okay, so firstly, when this thing changes, you can see that the graph moves up. Okay, when I add to the equation, it moves up. It shifts the graph up. That's the first point. Okay, let's take another graph and see what happens. Let's take the graph of y equals x plus 3, which I'm going to put up over there. And let's take the graph of y equals x, right? Y equals 1x. Okay, so as you can see, once again, this graph over here is the graph of y equals x plus 0, which is the same as y equals x. And this is the graph of y equals x plus 3. Again, the incline or the gradient remains exactly the same. The gradient's value for each of these graphs is 1, because there's a 1 in front of the x. So the gradient is 1, and you can see if a man runs up here and he runs up here, he has to put in exactly the same effort. Okay, so the gradient didn't change. However, the graph moved upwards. By 3 units, right? It was pushed 3 units upwards. That's our observation over here. Okay, now the next question we need to look at, people, is let's do one more and see what happens. Let's take the graph of 3x, y equals 3x plus 3, and compare that with the original y equals 3x. I'm going to put y equals 3x over there. I'm going to switch that on. Okay, again, this is the graph y equals 3x, and this one over here is y equals 3x plus 3. In both cases, what do we notice? Well, the incline didn't change because 3 is the gradient. So the steepness of the blue curve and the steepness of the black curve over here are exactly the same. But this is plus naught, which is exactly the same as just 3x. So I'm going to bring you to an important observation that we will discuss in more detail in the next video with what this represents now. Okay, and I'm going to give you an intro. This represents something called the y-intercept. Okay, to be discussed further in the next video. Okay, so your observations for Q, if we look over here, if we look at Q, this constant, right, represents a vertical shift. Okay, before we go into the